Alrighty, so we've learned a lot about quadratic functions up to this point and how they change the shape and position. So let's just do a little recap here. When it's in vertex form, meaning when I look at the equation, I can actually read what the vertex is. Which letter determines the shape, whether it opens up or down? Well, that would be A. Which letter translates the position of the graph horizontally? That would be P. And which letter translates the position of the graph vertically? And that would be Q. So not all the time do we have the quadratic equation in vertex form where we can read it so nicely like that. Of course not. We have to have it in what we call general form. So general form is when basically the x minus p is multiplied out, and we have it in the form f of x equals ax squared plus bx plus c. Of course, a can't be 0 because then it wouldn't be a quadratic, because 0 times x squared would wipe away your x squared, and then you wouldn't have a degree of 2 anymore. So we're going to use graphing technology to see the results of changing the value of c. So we have this equation negative x squared plus 4x plus c, and we're going to change the value of c so it's 10, 0, and negative 5. So if you don't have a graphing calculator, you can use the graphing website that I have above. So again, we're doing negative x squared. So negative x squared. And it was plus 4x. So plus 4x. And then we're going to use 10, so plus 10. And we'll graph that. And so we can, you can see how it's higher up. You can zoom out a little bit so we can see it a little bit better. And we're going to do the same one again, negative x squared plus 4x. But this time we want plus 0. So if you want, you can put plus 0. You don't really need that because it doesn't really do anything. So that will be my green one. So is it the same shape? What's happening there? So then now we're going to do minus x squared plus 4x. And then this time it's going to be subtract 5. So what do you notice about the graph when I change the c? Are we changing the is the vertex moving at all? Well, it's not moving left or right, but do you notice that it is moving down here? So what else do you discover? Well, let's look back at this graph here. Where does it cross the y-axis here? Oh, look, 10, 0, and negative 5. So it does actually change the graph more than you think. So what do you discover? We could say the c is moving the graph vertically, up or down, depending on what it was. And the other thing we discovered was the c was equal to the y-intercept in that form. All right, so let's now see what happens when I change the a. So an ax squared plus 4x plus 5. And we're going to use various forms here. Okay, so again, we're going to change the value of a here. So the first one was negative 4x squared plus 4x plus 5. There's the graph there. The other one was negative 4x squared. Oh, sorry, I'm changing that to a 2, so let's change that back. So negative 2x squared. Again, it's still the same one, plus 4x plus 5. Let's see what happens there. Looks a little bit shifted. What happened there? Got wider, got narrower. What's going on? And then we're going to have a as 1. So if a is 1, I can put the 1 if you want, just to show I put 1. X squared plus 4x plus 5. We're going to graph it. And then we have a 2 plus 4x plus 5. Yellow's a little harder to see here, but so anyways, what's actually happening here? So, well, we know a little bit about the A, right? When did it open down? When did it open up, right? We know if the A is negative, it's going to be opening down, right? What happens to the width of my parabola if the number gets bigger? It's easy to compare my blue graph to my yellow graph. My yellow graph is way narrower than my blue graph. And even if you compare my green graph to my red graph, the red graph, which is A is negative 4, is way narrower than my green graph. So let's write down what we discovered. So when A was less than 0, it opened down. When A was greater than 0, it opened up. When A was greater than 1, it got narrower. And when A was, well, we didn't do any fractions, but we know from the past, when A is between 0 and 1, it got wider than the x squared graph. Okay, so now we're going to use technology to see what happens when we change the value of B. And we change the value of B. Okay, so it's negative x squared. Instead of the B now, I'm going to put minus 4x plus 5. So we knew it was going to be down, but we're not looking at whether it opens down or not because we knew all these graphs are going to open down. It's what's going to happen when we change our B. So now our B is going to be subtract 2. So what's happening there? Remember, nothing's changing with my 5. You can see it's still intersecting at the 5 on the y-axis. But what's actually happening when I change it from a 4 to a 2? Okay, well, if you haven't discovered yet, let's keep going. X squared, and we're not going to have a we have 0 there, so if you want, you can put plus 0x, but you don't need to. You can just leave it blank. Plus 5. So it's moving. And then the last one, negative x squared plus 2x. Moving more. So what's going on here? You can see that the height of the yellow and the green here, the B is positive 2 versus negative 2. They're the same height, but one's on one side versus the other. You notice the minus 4x is on the minus side, and the plus 2x, I guess, is on the right side. So does that have anything to do with it? So basically, the b is moving it left and right. So let's put that down. The b is shifting left or right. Okay, so next page. So let's expand, and this, some of you might have trouble expanding this, but do you remember your FOIL technique? You got to be able to FOIL out x minus p. So I'm just going to go x minus p squared on the side just to show my work, and then I'll multiply it by a. So that's the same thing as x minus p times x minus p. So do you remember our FOIL technique for binomials? So x times x is x squared. Outer we get minus xp, inner we get minus xp, and last we get plus p squared. So if I combine the middle two terms, I get x squared minus 2xp plus p squared. So now I'm going to go back and put it back into there. So y equals a bracket x squared minus 2xp plus p squared plus q. So now I'm going to multiply this all in. So y equals ax squared. So what I'm going to do is multiply the a into all three terms here. So ax squared minus 2axp plus ap squared plus q. So recall that x equals p is the x coordinate of the vertex, meaning whatever that number is, the axis of symmetry, like say you have the parabola, it's going through that x coordinate of the vertex there. So I guess what I'm trying to say here is if it's p, then what are we looking for to get the actual vertex here? So if x equals p, there's two p's here. So now if we compare this equation to this equation right here, does everybody see that it's very similar? If I write it right underneath it, y equals ax squared plus bx plus c. So the one that has the x is actually this part of the equation, and the one that has the c is this part of the equation. So what am I getting at? If I actually solve for b right here, that b would be basically minus 2ap. Look at that equation, compare the x's, and maybe I need to put the p in front of the x so you can see it a little bit better. But b is equal to 2ap, which means p, if I solve for that and then get rid of the minus 2a, it's b divided by minus 2a, which basically that's what I'm saying here is if it's in general form, the x coordinate of the vertex is minus b over 2a. So it's as easy as that. Determine the axis of symmetry of the parabola. Well, look at this. A equals minus 2, b equals 5, and c equals minus 3. If the x coordinate of the vertex is equal to minus b over 2a, that means it is minus 5 over 2 times minus 2, which is minus 5 over minus 4, which is 5 over 4. So I guess what I'm trying to say here is the coordinate of the vertex, I don't know what the y value is, but the x value is 5 over 4. But I don't really need to know what the y value is in this question because it's asking for the axis of symmetry. Remember, the axis of symmetry is a parabola. It goes to the vertex and it's x equal whatever that coordinate is of the vertex. Well, if I know my x-coordinate is 5 over 4, therefore, the axis of symmetry, I'm going to call the axis of symmetry AOS for short. AOS is equal to, colon x equals 5 over 4. So now there's a question, just rewrite into general form. Again, a lot of the times we have trouble with our FOIL, so I'm going to take apart this FOIL and do it on the side here. So x minus 4, the whole thing squared, means x minus 4 times x minus 4. So first we get x squared, outer we get minus 4x, inner we get minus 4x, and last we get plus 16. We combine the middle two, we get x squared minus 8x plus 16. When you get really good at this, you don't even have to write this out. You can actually picture the FOIL. So I'm going to write this out again. Y equals negative 3. Instead of the x minus 4 squared, I'm going to write x squared minus 8x plus 16, and then plus 3. So I'm just resubstituting what I FOILed out that to be. So y equals negative 3x squared. So now I'm going to do the distributive property. Y equals negative 3x squared plus 24x, and 16 times 3 is 48, so minus 48 plus 3. I got to combine those two together, and I get y equals negative 3x squared plus 24x minus 45. And so that is my equation in general form. So again, if I want to find the vertex of the parabola, remember that x equals minus b over 2a. We didn't talk about how we got our y coordinate though. So let's see. There's my a, there's my b. Because I don't care about the c and my x-intercept of the vertex, that's all we need. So minus 8 divided by 2 times minus 2 is minus 8 divided by minus 4, which is positive 2. So 2 is the x-coordinate of the vertex, but I don't know what my y-coordinate is. How do I figure that out? Well, it tells you. Y is whatever your x is squared times minus 2 plus whatever your x is times 8 minus 5. So plug it in. Y equals negative 2, and because I know the vertex x is 2, I'm going to put 2 in for the x. So 2 squared plus 8 times 2 minus 5. So that's negative 2 times 4 plus 16 minus 5. So that's negative 8 plus 16 minus 5. And negative 8 and negative 5 is negative 13 plus 16 is 3. So that means my vertex is at 2, 3.